Hi everyone, so today we're going to be starting Unit 8, and we're going to start this unit, which is mostly about factoring, with learning about something called GCF and factoring using the GCF. So first things first, GCF stands for greatest common factor. So greatest common factor. And we can find the greatest common factor between two or more different things. So we can find the greatest common factor of two numbers, which we're going to do first. And if you think back, probably a long time ago you made factor trees. Well, those are going to kind of come into play again, although you don't have to make factor trees all the time if you don't want to. So if we're going to look for the greatest common factor between 9 and 12, we're looking for the greatest number that goes into both 9 and 12. So if I do a factor tree, quick one, of 9, I see that it's 3 times 3. And those are the lowest factors I can get to. 12 is going to be 3 times 4, and 4 is 2 times 2. So those are my prime factors. So my greatest common factor, well, I have one 3 here. I match it with another 3 over here. The only other thing I have with 9 is a 3, but I don't have another 3 with the 12. So my greatest common factor is 3. The greatest common factor between 15 and 50, well, maybe we don't have to use factor trees. Maybe we can kind of just list it out. 15 is 5 times 3. And 50 is 5 times 10, and we know 10 is going to be 5 times 2. So this is 5 times 5 times 2. So the greatest common factor here is going to be 5, because I can't match any other thing with anything in the other number. So my greatest common factor here is 5. Now with 8 and 11, if I factor 8, I'm going to see that that's, well, 8 is 2 times 4. 4 is 2 times 2, so I have 3 2's. 11 is just 11. I can't really factor it. It's already prime. So I don't have any common factors here. So my greatest common factor is 1. All right, let's move on to the greatest common factor of some monomials. All right, so in addition to finding the greatest common factor of numbers, we can also find the greatest common factor of monomials. So if we're going to do that, we're going to treat variables like part of our greatest common factor. So if I have 3ab squared and 3b, well, I can already tell I have a 3 in both of these and a b over here. Well, I have b squared, which is just b times b, so I have 1b there, at least. So my greatest common factor here is going to be 3b, because I can fit 3b into both of these. But for this one, I'm limited, because I can't fit any more than 3b into it. All right, for number 6, I have 125s squared and 50s. Well, with 100, I know that's 25 times 4. Maybe I'll leave it at that, because I already see that I have a 25 over here, and I have 50, which I know is 25 times 2. So I know at least 25 goes into all 3 of these monomials. And I have s's over here. I have 1s and s squared. But with the 100, I don't have an s, so I can't count that in the greatest common factor. So my greatest common factor here is just 25. Now for number 7, I'm going to see how many a's and b's I can fit into all 3 of these terms, and I'm going to look at these numbers. So I know 8 is really 4 times 2, and if I look ahead, I see a 4, and I see a 12, and I know 4 times 3 is 12. So I know that 4 goes into all 3 of these numbers, but nothing bigger because 4 is one of them. Now I have to look at the a's. Well, now I'm going to have to figure out what's my a term that's my limiting factor. What's limiting me from going higher? Here I have a to the 4th, but here I only have a to the 3rd. And here I only have a squared. So I can't get any higher than a squared. So I'm going to take this guy out, so I'll have a squared. And now every one of these terms has b to the 3rd, so I'm going to keep that too. b to the 3rd goes into all 3. So altogether, I have 4a squared b to the third. That's my greatest common factor that goes into all three of these monomials. All right, now let's go into some examples where we factor polynomials using the GCF. Okay, before we do these examples, let's talk a little bit about factoring. So if you remember, when we had something like 3 times a plus b, we did something called distribution. I think we're all pretty familiar with this, where we distribute this 3 to the a and the b, and we get 3a plus 3b. Factoring is going backwards. Factoring is like reverse distribution. So we're going to take something like this and pull that 3 back out. But in order to know what we're going to pull out, we need to know the greatest common factor. So the greatest common factor of this polynomial right here happens to be 3. So we're going to do the same thing with these polynomials over here. So with number 8, we have 4a squared plus 2a cubed. Well, already I can see that I have 4 and 2. And I know 4 is just 2 times 2. So I can at least pull a 2 out from both of these. So I'll put 2 over here. And then I also notice that I have a squared here, but I have a cubed here. Well, a cubed is really just a times a, and a squared is a times a. So my limiting factor here, my limiting thing, is that I have a squared. The only thing I can take out is a squared. So I have 2a squared, and then the rest I'm going to pull out and put in these parentheses. So from this first term, I took 2a squared out, but I'm still left with a 2. So I have 2 plus, what's left when I take 2a squared out of 2a cubed? Well, I have an a left. So I'll have 2 plus a. And you can check yourself, you can always check yourself by distributing. So if you distribute this, you should be able to get back 4a squared plus 2a cubed. And in fact, we do. Okay, number 9, I can see I have 3 and 6. Well, 6 is just 3 times 2, so I can pull a 3 out. And I have y squared and y. So I'm going to pull a y out, and that's all I can pull out of this guy. So what I'm left with is 3y and then times. I'm going to have a y here that I didn't use, so y. And I'm going to have this 2 here that I didn't use before. Once again, if you distribute, you should be able to get the same thing that we started with. All right, for number 10, I have 5 and negative 15. Here's a trick. If the majority of my terms are negative, I'm going to pull a negative out. But if it's not a majority, I'm just going to pull out a positive number. So I have 5 here, and I have 5 times negative 3 here. I also have x times y, and then I have x times x. That's x squared, right? So the only thing I can pull out is an x. So I'm going to pull out a 5 and an x. And what I'm left with over here is a y. And I got to keep that minus in there. So y minus 3. So I got a 3. And that x to make it x squared. All right, number 11. Number 11, well, let's see. We have a 2 and a j over here. And we have a 7 and a k squared. So our variables don't overlap at all. And 2 doesn't go into 7. So our greatest common factor is going to be 1. That means this guy's already factored the way it is. We're good. Okay, number 12 has 2x cubed plus 6x squared plus x. Well, right away, I notice that I have this lone x over here, which nothing goes into except x. So automatically, I'm already thinking, okay, I can probably only take an x out of this if it goes into my other terms. And in fact, it does. I have x cubed and x squared right here. So the only thing I can take out is an x. And what I'm going to be left with is 2x squared plus 6x plus 1. And if I distribute, I should be able to get the same thing. 13, I have negative 15f minus 10f squared. Here, the majority of my terms are negative. So I'm going to pull out a negative, at least. And I have 5 times 3 here, and I have 5 times 2 here. So I can pull out a 5. And let's see, I have an f here and an f squared here. So I can pull out an f. And what I'm left with is 3 on the left and 2f over here. And this is going to be a plus because my minus, my negative here, distributes to both of these terms. All right, 14 has 4jk cubed plus 6j squared k plus jk. Well, this kind of looks similar to this one, where I have only a jk over here, j times k. So the only thing I can pull out of this is a j times k. And I'm lucky that j and k both go into my other terms. So I can pull out jk, and what I'm left with is 4k squared plus 6j plus 1. All right, and with that, I will leave you to try the problems at the bottom of your guided notes. Thanks.